Okay. All right, so here we go. All right, so first problem. All right, so this is one where we have these 3 questions we have to answer. So, first question, growth or decay? Decay. How do we know it's decay? Less, that number's less than 1. What is the percent growth or decay?
39%.
So, what did you say the percent growth or decay was? 39%. That's right, because this number is 30 or 0.39 less than 1. So that means it's 39% decay. What is the initial value? 0.82. All right, that's easy. Got that one done. All right, now we are going to write the equation of the exponential function that contains these 2 points. All right? So here we go. What do we do?
Y equals 1/2, or 81/2 equals 1/2.
First of all, we remember that this is what we are aiming for, right? That's the format we want. Now, if we paid attention, we have noticed what about this point? This is the point we normally start, that we should start with, but what always happens? A turns out to be that number right there every time.
That's mother.
So y equals 1/2 b to the x is where we are right now. Right? Okay. So now what? We take this point and we plug it in right here. So 81/2 equals 1/2 b to the 4th, because I'm plugging in my x and my y, right?
Yeah.
Okay, so now what do? I gotta figure out what b is. Step 1, I'm gonna multiply by 2. Now you could say divide by 1/2, but that would be messier. It's easier just to multiply by 2. So 81 equals b to the 4th. So then we
3.
4 through both sides. So b equals
3.
the 4th root of 81. Now, maybe you don't know that's 3. You need to be able to figure it out. So if you start breaking 81 down, just 3 times 3 times 3 times 3 times 3. On the no calculator part of the test, I'm not going to give you wild, wacky numbers. I mean, it's going to be something that actually you should know, but if you don't, it's going to be something that's easy to figure out. So the answer is y equals 1/2 times 3 to the x. Remember, your answer is the actual equation. You have to write that down. Don't just say b equals 3. You have to write it down. All right, now we got a whole bunch of things that say simplify, and still we're on the no calculator. This is no calculator. So, first thing you should see here, hopefully, is a negative exponent. So that means we flip it. So we have 1/81 to the 3/4 power. What does that mean?
1/81 cubed, and the 4/3 of that.
It means a 4th root. So we're going to take the 4th root of 1/81 and we are going to cube it. Right? So the 4th root of 1/81, well, luckily we just did that. The 4th root of 81 is 3. Then I cube it and I get, don't forget it's 1/, though. It's 1/27. Okay? Don't forget the 1/. All right. Okay, how about the next one? 2 to the negative third. This one's easy. That's 1 over 2 cubed, which is 1/8.
Miss Ford, do you have an extra practice set?
Yes, sir.
No, take a picture of somebody.
Okay.
All right, C.
Marky, you can't take a picture of that.
You flip it to 9/4. 9/16.
And then
All right, who's missing? Is there someone
Pop
missing here?
Pop is back here.
Oh, Pop's back there, okay. All right, so now you've got 16 ninths to the negative second. What do we do with 16 ninths to the negative second?
flip it.
First we flip it, so 9/16, and then we square it, so 81 over 256. Now, you might not know what 16 squared is, and that's okay, you probably should, but it's sorry if you don't. But if you don't, you're gonna have to do the multiplication
Yeah,
and figure it
calculator.
out. There's no calculator on this part of the test.
Wait, so
All
how
right.
will you know?
It's called math on paper. That's hard,
Yep,
but we gotta get through it.
we will get through it.
Let's go.
All right, now this one is easy if you pay attention to the fact that ln and e are touching each other. And when ln and e touch each other, they cancel out. So the answer is just -6. There is no need to do any work. They touch each other, that's it. Log base 5 of 25.
This one's loop-de-loop.
This one's gonna be a loop-de-loo, as Hugh says. It probably would help you to think of it as equals x, even though that isn't written there. And then 5 to the x equals 25, so x equals 2. F.
Alright, this one,
You got me this for the email.
So,
You don't flip it.
one at a time, let's take care of what's inside the parentheses. So, what do we got in there?
Yeah, flip that.
We got 3 over 4. Remember, if that reduces, you want to reduce it. So it doesn't, but if it had been 4/12, you would want to reduce that before you moved on with the problem, or it's going to be harder for you. So reduce this if you can. Now, both of these are negative, right? So when you're negative, you have to flip. So this is basically going to be x to the 4th on top and x cubed on the bottom, right? So now I have 4 x's on the top and 3 x's on the bottom. Who has more? The top. How many more? 1 more. So there's an x left over on the top. Now, let's look at the y's. Nothing flips, it's all positive, leave it alone. But you have 2 y's on the top and 1 on the bottom. Who has more? The top. How many more? 1. So you have a y on the top. Now that you've got all that cleaned up, now we can square everything. So we start squaring everything, including the 3 and the 4. That would be 9 over 16. And x squared, y squared. Oh, I think that's my doctor.
Give me an M. Give me an H. Give me an
Yeah, what's up, man? Hey, that retreat letter, though.
Yeah,
You didn't add here?
Okay,
Hey, Larry was nice.
all right. So now we're on to G. Well, luckily, G is another really simple one. That if you've been paying attention to what we talked about, you know the answer to G is 12. Because the 3's cancel out. Seth?
For like the, sorry, on the last problem, we did that too. And we said if the exponent was like 4, would you multiply the 4 times 2 or do you add it?
What are you talking about?
Like when we had the parentheses at 2
Right.
for exponents,
Right.
do you add it or do you multiply it? You multiply it?
If you're raising a power to a power, you multiply it, yes. Okay, so G is 12, that's easy, no work. But now we're looking at this problem. This is not quite so easy. So again, you might want to do what Hugh suggested last time, and that is set this equal to X. And then what, Sam? You need to remember that LOG all by itself means base 10. So when you loop-de-loo it now, 10 to the X equals 1/10.
Yeah.
So what power would we raise it to move that 10 to the bottom? -1, just -1. So
Wait, do we have G?
that one
It's easy.
is -1.
G is 12.
All right, I. Negative exponent,
Flip it.
flips it, so 4/3. Now we gotta square it, so the answer is
16 over 9.
16 over 9, that's it. And then what about J? It's 6.
6.
Anytime an E and an LN are
Cancel out.
touching, they cancel out. So the answer would just be 6.
Brother.
Okay, now we've got an equation to solve. Okay. Shh, stop it.
That's what I'm saying.
How do we solve this equation? Don't make it hard. This is an easy one.
No, loop it. Loop that boy.
Just
Loop-de-loop.
So 4 cubed equals x plus 1. There's no difference to this than this one over here. It's the same setup. So 4 cubed means 4 times 4 times 4.
64.
64 equals x plus 1.
63.
So x equals 63. Nothing to be confused about.
This one's hard right here.
Oh, this is loop-de-loop. No.
You're not ever gonna loop-de-loo unless the
Oh, wait, no, I
problem
was
has a
looking at E. I was looking
logarithm
at
in
E.
it, right? So what do we do first here?
Divide by 4.
Divide by 4. If there's an extra number in the
Oh,
problem,
yeah.
you have to get rid of it.
But if you just plug in 2, you know that.
So 3 to the x equals 9. So x equals 2.
Yeah.
You have to guess and check though.
Can you guess and check that?
You can guess and check all you want, Hugh, but you gotta be done at the end of the period.
Yeah.
Oh, come on.
All
9 by
right,
3.
so now we have this problem.
Can I get any credit for that video anymore?
Now we're gonna divide both sides
100.
by 3.
Yep.
Anytime there's an extra number, just like this one over here, same situation,
Just a
we're gonna divide it out.
That is great.
So the log of x equals 2.
10 squared.
Remember, that base is 10. So 10 to the second equals x. And those of you that thought it was 100, you are right, it is 100.
They must have said food was on the table.
All right, this one looks a lot like this one. Certainly it has an extra number in the front of it, right? So we're gonna get rid of that.
Divide by 20.
So 1/3 to the 2x equals,
It's 27.
Yeah,
you got to divide by All right, now, I need to simplify that, so 243 divided by 27,
What is that? What is that?
I think it's 9. It's 9. So that reduces to just 9.
Wow. Uh-oh.
Now,
What do you do here?
So negative 1, negative 2.
I need to get a common base,
Negative one.
right?
Now return it to negative 2.
Or negative 2.
So, since this is a 1/3, would you agree there has to be a negative in there?
For sure.
So this is 3 to the negative first,
Oh.
but I'm gonna raise it to the 2x. So 1/3 is 3 to the negative first, 1/3. And over here, I have 3 squared.
Common bases.
Now that the bases are the same, I can just look at the exponent part.
So it'd be negative 1.
So negative 2x equals 2, and x equals negative 1.
So, is there something that we should be like looking for that we know like, okay, like now we need to find a common base?
Yep. If you are solving for an exponent without a calculator, the only way to do it's with a common base.
Yeah.
If
Not
you're
easier?
solving for
How-
an exponent without a calculator, you gotta get a common base.
Is it not easier by just looking at that and seeing that negative 1 flips that around and be 3 times 3
So, okay.
instead of doing that work?
I'm doing the work in case you can't just look at it and see that. And remember, if you look at it, see it, and put the wrong answer down, and you've got the wrong answer, there's no partial credit for a yes, right? Not worried about it, okay. All right, here we go. Next problem. Now, this is a logarithmic equation, but there's something that needs fixed.
3x
Yep,
times.
bring it in.
Bring it in, that's
Multiply
right.
that 3 to the.
These two have got to be combined into one. Now notice when I combine it, there's still a logarithm. There's one logarithm now instead of 2 logarithms. When I combine them, I will always combine them as a multiplication or a division. Those are your options. Looking at this problem, seeing this right here, tells you you're going to combine them as a multiplication. So 3x plus 3. I'm going to multiply these two things together.
And live to it.
Now, since there's only one logarithm, now I'll loop-de-loop. So 4 to the first equals 3x plus 3. 1 equals 3x, and x equals 1/3. You cannot loop-de-loop. You can't do anything until you combine those two logarithms into a single logarithm.
Miss Ford,
What?
so say like, that wasn't 4 to the first, like, if that was like 4 to the second, do I just still do that? Like, I make it 16?
Mm-hmm.
Did you get the 1 from the equal 1?
Yeah.
Okay.
Loop-de-loop,
Well,
Sam.
no.
All right, so now I've got the next one. And as I'm writing it down, I'm noticing I've got the same issue over here on this side. There are 2 logarithms. You have got to put those together. These have got to be put together in step 1. When you put them together, they're going to go together as a times or a divide.
Hey, don't do this, don't do this.
Since that's a plus, they're going to go together
Multiply.
again as a multiply. So it'll be 18x plus 9.
Yeah.
Cancel out the log.
Cancel out the log.
This
You have a common
problem,
base, so
this problem looks different than this one, because this one didn't have a log on both sides, so I had to loop-de-loop it. This one does have a log on both sides, so I can just lose them.
Let's go.
So 18x plus 9 equals 3.
So minus 9.
18x equals negative 6.
just 1/3.
and x equals negative 1/3?
Yeah, I got that. Oh, I'm tripping. You're right. No, it's because divided by 18.
Divided by 18.
Why would it be?
Because you divided by 18 on 6. Boy!
All right. One logarithm in the problem. When there's one logarithm in the problem, there's no extra numbers to divide by, so I go straight to the loop-de-loop.
Let's go.
Now, remember that ln means log base e. So when I loop-de-loop this, it's going to say e to the third equals 2x. So x equals e to the third over 2. And that's how you leave it. You don't have a calculator. There's no way to know what number e cubed is, so it just stays e to the second over 2. Or e to the third over 2. All right.
Find common base.
We're looking for an exponent.
2.
We do not have a calculator.
Show where the 2 to the 5th.
So 4 and 32 can both be written as powers of 2.
Yeah.
Now again, if you don't know that 32 is 2 to the 5th, you can figure it out. 2 times 2, just keep timesing 2's until you get to 32. It takes 5 of them. Once you have both of them with a common base, then 2x equals 5,
They evolve.
and x equals 5 halves. All right, 2 more without a calculator, and then we've got to use a calculator.
Logarithm.
So here we go.
No, I know.
This one says, put these two together. So just like that problem that I just erased, when we put them together, that's what you're doing here. So when you put this together, it will go together as a multiplication, right? But there's something you have to take care of before you multiply. You remember what it is?
You gotta turn it into exponents.
These guys have to turn into exponents. So this is the log of x squared plus the log of y cubed. Just like when you take the logarithm, you're allowed to pull the exponent off, you're also allowed to put it back. So this becomes x squared, this becomes y cubed. Now I can write it as a single logarithm. What goes in the parentheses?
Log x squared y
X
cubed.
squared y cubed. Multiplied together because that is a plus. Right? Now, the next one is the exact opposite of that. Separate this into multiple logarithms. So you're doing the opposite now. You're expanding it. So you're going to have the log of x, the log of y, and the log of z. Now, what do I put in between there? Well, what's happening to these two numbers, x and y? They're being multiplied, so when they get pulled apart, they will be a plus.
Oh, that was easy.
That is a division, right? That's being divided. So when that gets pulled apart, it is a minus. Think about putting this back together. Wouldn't you multiply the x and the y
Yeah, I saw that.
and divide the z? Yeah, you're just doing the opposite of that. You're just separating it. All right, now we need a calculator because we're not going to have common bases from now on, so we need to get a calculator going here. Okay, so here we go. how do we start this problem? This is 7A.
5 equals 10.
So we start by loop-de-looing it. We've got a logarithm we'd like to get rid of. So 5 to the x equals 10. Perfect. Now, if I could get a common base at this point, that's what I would do. But there's no common base between 5 and 10. Now, sometimes kids get confused and they say, wait a minute, Mrs. Ford, 10 is 5 times 2. That's right. But when we say common base, we mean, is 10 5 to some power? And the answer is no, it's not. So the only way to solve it now is to take the logarithm of those sides. So I got rid of the original logarithm by loop-de-looing. Now I'm going to put in new logarithms so that I can take this and pull it off out here. So now it says x log 5 equals log 10. Right?
Yeah.
And then I'll divide, so x equals log 10 over log 5, getting x by itself, and then I'll go to my calculator, and I'll talk to you about making sure that's in parentheses.
1.43.
So log 10 divided by log 5, and I think it says nearest thousandth. Oh, it doesn't, but I think it does on the test. So let's round it to the nearest thousandth. 1.431. Thousandth is 3 places, 10,000th is 4 places. All right, that wasn't so bad. How about this one?
Divide by 3.
Divide by 3. You have to divide by that extra number, just like before. We do it every time. Calculator, no calculator, doesn't matter. Doesn't that look kind of like this looked right here before I took the log of both sides?
Yeah.
So we're going to do exactly what we just did. So we'll take the log of both sides. X comes out in front. And then we'll divide. So it's going to be the log of 5 divided by the log of 2. So the answer should be 2.322.
How you start doing what?
There's no way you can wait till the passing period.
I'll take his notes while he's gone.
How much longer is it?
I don't know. Let me get done with this and then I'll let you go. Right? This practice test. All right. Here we go. What do I have to do first?
5 by 5.
Divide by 5. It doesn't matter what the problem looks like. If there's an extra number out there in the front, you've got to divide by it.
2.5. 5 no.
2.4. But if I can't do that in my head, I'll probably just leave it alone until this. But it's 2.4. Now what? Yeah, this is exactly the same problem, but since it has an E in it, I'll ln both sides.
LN Wildcats.
That cancels.
Now, do you see ln touching E? Gone. So 0.13x equals ln 12/5. And then we'll divide. So x is ln 12/5 divided by 0.13. And it's 6.734 if I type that in right. All right, now we've got our word problems. Okay, so there were 3 of these. Bless you. There were 3 of these on the last practice test. There's 3 of them here. My guess is there's 3 of them on the next practice test. So what do you think's on your test? 3 word problems. So if I were you, when I got my test, I would write my 2 formulas down at the top. Because the first thing you are going to have to be able to do is decide which formula to use. So all these problems are going to be kind of like just plug in the information, but you have to know where to plug it in, which formula. So here we go, the first one. What interest rates required to double an investment in 11 years if the interest is compounded monthly? That's your key. Compounded monthly is this one right here. So this is the formula we're going to use for problem A. Well, it doesn't matter that it didn't give you A or P. What do you know about the relationship between A and P?
They're equal.
They're not equal. A is double P. So I can start with whatever money I want. So if I want to start with $18 because it's Sam's 18th birthday. If I start with $18, then I know I'm going to end up with $36. If you start with $25, you're going to end with $50. You're going to end up with exactly double of what you started with, and you'll see in a moment why it doesn't make any difference. But I talked about that before in the video. All right, so here we go. 1 plus. All right, now what do I want to know? What interest rate? So I don't know R, do I? That's my unknown. What's my N? 12, because I compounded monthly. Remember that that N and that N are the same number, so whatever you decide for N, it goes in twice.
Then it's 11.
11 years. T is 11 years.
What would the number be for yearly?
1. Now, I am going to go ahead and multiply 12 times 11. I learned that in like the 4th grade, but I can't remember what it is. 132? I'm just going to take care of that right away. All right, now, I want you to look at this problem, and I want you to tell me what step 1 has to be.
Divide by 18.
Divide by 18. Do you see you have this extra number tacked out here? It's got to go. Now, what's going to happen when I divide by 18?
2.
I'm going to get 2. Now, remember when I told you it wouldn't matter what you started with and ended with? Because look what's going to happen. If you started with 25, you'd end with 50, what's going to happen when you divide? You get 2, right? If you started with 100 and ended with 200, what's going to happen when you divide? You get 2. It makes no difference what you start and end with, as long as they're double. The end is double the beginning. So now I've got this equation. Now that is tricky. How am I going to solve that?
So we're gonna log?
Now, I am not going to log. Can somebody tell me why I'm not going to log?
Because there's no, like,
The x
You're
is
gonna
not
divide?
in the exponent.
you're gonna divide?
Divide by
The
1.
only time I log, guys, is when my variable's up here, so that I can pull it off out front. My variable is not up there. I want you to think about, let me simplify the problem a little bit. What if the problem were this? How would you solve that problem right there? You would cube root both sides. Isn't that how we get rid of that exponent? We cube root both sides. So I am going to now 132nd root both sides. Now, Why do I do that? Because if I 132nd
Has to be
root
one plus.
this, all I'm gonna have left over here is this, right? To get rid of a power, you root it. You've done that your whole life. You've gotten problems like this. How do you solve that? You square root both sides, right? That gets rid of that power. This is just a bigger power. Now, I gotta type this in on my calculator. Because whatever that number is, I'm gonna subtract 1 and multiply by 12 to get my answer. So, in case you don't know, I think we went through this one day, but maybe we didn't. If you need to take the 132nd root on your calculator, any root, type in the root, so I'll type 132. Then I'll go to my math menu, and down the list, for me it's number 5, I have a button that looks like this. So I press that button and press enter, and then I'll put in my 2, and this is 1.005264926, . So one more time, to get this, I need to get it calculated. So to get this, I put in 132, I go to math, press the math button, and press this option, and then I put in the 2, and then hit equals, and it gives me this. Now, I am gonna leave this on my calculator, so it's right here. I need to solve this. So can you see I need to subtract 1? So I'm gonna subtract 1. So now that's gone. So what do I need to do? Multiply by 12. I can do all that on my calculator. And R turns out to be 0.063. So what's the answer to the question? It says, what interest rate? What are you going to say? 6.3%. No.
Yeah.
All right, B.
Miss Ford, do you have any like tricky way to like remember like an acronym or anything to like remember which equation goes with which? You know what I mean?
I don't know.
Like,
No,
is there any?
this formula only works with compound interest. The only time you're ever going to use that first one is with compound
Wait,
interest.
memorize that formula?
Yes.
Yeah.
So now I go to question B. How much will be in the account at the end of 12 years if I invest this money at this interest rate compounded quarterly? It is the same thing. That's right, Derek. It's the same formula. So here we go. Question B. What goes in for A? A is what I'm looking for. What goes in for P?
2,000.
10,000. What goes in for R? Watch it. 0.02175. What goes in for N? 4, both places. And what goes in for T?
12.
12. So I'm going to go ahead and make that 48. Do I need logarithms to solve this one? No, and in fact, I don't need to do anything. I want to know what A is. So I'm going to type in exactly what I wrote. If you type it in exactly the way I wrote it with the parentheses and stuff, and remember that this means raised to the 48th power, you will get the right answer. So 10,000 parentheses, 1 plus 0.02175 divided by 4, close parentheses, raised to the 48th equals $12,973.10.
That's crazy.
remember, don't ever mess around with logarithms unless your variable is up here. If your variable is up here, then you're gonna need logarithms. Otherwise, just type it in. All right, C. I know it's per right from the beginning because it's not even a money problem, right? Doesn't have anything to do with money. It's a population problem. What is the growth constant for logarithmites if a population of 432 grows into 987 in 15 hours?
So it's 987 equals 432.
So 987 is what I'm ending with.
Equals
432 is what I'm starting with.
R.
I don't know what R is, but T is 15.
So
Am I going to need logarithms?
No.
yeah.
Yes, because my exponent is my variable. When your exponent has the variable, that's your clue you're going to need logarithms. But what am I going to do first? Divide by the 432.
Math is so cool.
Now, we need a logarithm to pull that 15R down, right?
Yeah.
Since the problem has an E in it, I think I'll use the LN brand of logarithms. Could I LOG? Yes, but it's easier to LN. Because why?
The E's crossed out.
That's gone, and this is just plain 15R. So to get my answer, it's going to be real simple. I'm going to take ln and divide it by 15. So ln 987 divided by 432, close those parentheses, divided by 15. It looks like your growth constant is 0.055. That would be it to three places. 0.055.
Is that a percent?
It could be, it's not absolutely necessary. This says what is the growth constant. So usually we leave that as a decimal, but if you change it to a percent, it would be, I would have marked it wrong.
Okay.
If it says what is the percent, you gotta write it as a percent. Growth constant's normally just a decimal. All right, that's it for that. So, I got a couple of things I want to do. So, if
We talk about
bathrooms, he's going to go to the bathroom. Oh, one person's going to the bathroom. If this isn't all, like we're all running to the bathroom.
This is middle school.
Here are some quizzes.
Great. Did we take quizzes last week while we were on retreat?
If
What was
you
it?
check Power School, you will see what you missed.